Thunderstrike 2 starts with a local root privilege exploit that can load a kernel module to give it access to raw memory. On some systems, it can immediately unlock and rewrite the motherboard boot flash. On others, it needs to hook the S3 resume script and wait for a sleep event. It can also search the PCIe bus for removable Thunderbolt devices and write itself into their option ROMs. This is an improvement over Thunderstrike 1, which required physical access to the attack machine. Like the original, Thunderstrike 2's proof of concept is not very stealthy, so when the system reboots, the logo is displayed and various hooks are inserted into the running EFI firmware. When the infected adapter is connected to a fresh laptop during a system boot, the option ROM is executed by EFI firmware before the kernel is started. The option ROM can't directly write to the flash, so instead it hooks the S3 resume script that will be executed when the system comes out of a sleep mode. We can identify when the system has entered the S3 suspend a RAM sleep by waiting for the fans to shut down. The vulnerability is that the flash protection bits are reset when coming out of this mode, giving the attack a window of time to write Thunderstrike 2 into the motherboard boot flash. Once installed in the boot flash, it is very difficult to remove, since it controls the system from the very first instruction executed upon booting. This includes the keys for updating the firmware. Reinstalling OS X won't remove it, replacing the hard drive won't remove it. Even swapping to a new laptop has the possibility of reinfection from shared Thunderbolt devices. Again, this proof of concept isn't very stealthy, so when the system reboots, we'll see the Thunderstrike logo. A weaponized version could use virtualization or SMM to hide from attempts to detect it. Thunderstrike 2 also watches for new Thunderbolt devices to be attached, and can write itself to a clean adapter when it detects the PCIe hot plug event. This hardware transmission vector allows it to potentially cross air-gap security measures. Thunderstrike 2's proof of concept demonstrates the entire cycle of a software exploit that can write to the motherboard boot flash, which then can infect Thunderbolt option ROMs, which can hook the S3 resume script or SMM and repeat the installation into the motherboard boot flash chips on new machines.